Assalamu alaikum. Welcome to all of you once again with Sayyid Kashif Mahmood. In this lecture, I am going to discuss about the concept of continuity. But before having discussion on continuity, we should know the difference between a continuous function and a discontinuous function. When we know the difference between a continuous and discontinuous function, then we will be able to understand the concept of continuity in more and more better way. So let's start from the difference between a continuous function and a discontinuous function, and we should know it through two basic graphs. So let me draw two graphs. The first one is this and the second one is this. So let's observe both of these graphs. The first graph, if you look here, we call this graph as the graph of a continuous function, and to the second graph we saying that this is the graph of a discontinuous function. Why we saying like that? So let me give you reason. If you look to this graph, so the line which is here, when it going from this point to this point, it going in a continuous form, which mean this line having no cutting, this line having no any jumping, it is in a continuous form. So that's why we are saying that if the line having a continuous form, having no jumping, having no cutting, so we call that as the graph of a continuous function. Let's come to the second one graph. If you look here, when the line is starting from here, so it is cut here. So when there is cutting or jumping in a line of a graph, so we saying that that is the graph of a discontinuous function. So I hope that the graph of continuous function and a discontinuous function is clear to all of you. If we look in our daily life, let's suppose I am saying that I am going from this point A to this point B in a continuous form. So what does that mean? That means that if I am going from this point A to point B, I am not stopping in between these 2 points. It means when I am going from point A to point B, in between I am not taking any lunch, I am not taking any dinner, I don't talking with the people. So when I am not stopping, I can say that I am continuous in between A and B. So if this is the initial point, this is the final point, if the line not stopping, not jumping, so that is the graph of a continuous function. So I hope this is clear to all of you. Now let's discuss about the concept of continuity. The concept of continuity telling to us that whether at a certain point the function is continuous or discontinuous. How it telling to us? So let's discuss that in little bit detail, and after that we will do one example. So I hope there will be no any confusion in your mind. A function f of x is said to be a continuous at x is equal to a if it satisfies the following 3 conditions. As I have said that the function of continuity is to know whether at a certain point the function is continuous or discontinuous. So Now let me tell you the three conditions through which we can know that the function is continuous or discontinuous. So the first condition is that f of a should be defined. It means that if we give a value, the answer should be in a defined way. The answer should never be undefined. If the answer is undefined, then the function will never be a continuous function. Let's suppose we are giving an example that f of x is equal to x square minus 4 divided by x minus 2. So let's suppose we are taking x is equal to 2. Now look here. So the answer is 0 divided by 0, and 0 divided by 0 is undefined. If there is 0 in denominator, so the answer be undefined. So if the answer coming in undefined way, so the first condition is not satisfied. So we can say that the function is not a continuous function. So this is the first condition, that the answer should be in a defined way. The answer should be like 1, 2, 3, etc. but should never be in this form. So this is the first condition. I hope it is clear to you. Now let's talk about the second condition. The second condition is that limit x tend to a, f of x exists. What does it mean? It means that the left hand limit should be equal to the right hand limit. Let's suppose from the left side we are getting 2, so from the right side we should also have to get 2. If we are getting 1 from one side and 2 from other side, then the left hand limit and the right hand limit is not equal to each other. Thus we can say that the second condition is not satisfied, because the left hand limit is not equal to the right hand limit. So these two values should be equal to each other. How are we taking it? Let's suppose we are having 2. So to this value we can come through two sides. One is this side, which we can say right hand limit, and one at this left side we can say left hand limit. So the value which we are getting from this side should be equal to the value we are getting from this side. Otherwise the second condition will never be satisfied, and when the second condition is not satisfied, then the function is not continuous. Now let me tell you about the third condition and the last condition. The third condition is that the limit x tend to a, f of x should be equal to f of a. What does it mean? It means that if I have got 2 in the second condition, so that should be equal to the value of the first condition. That should also be 2. If I got 2 here, so here also have to be 2. Otherwise it will not be equal to each other. And when these two are not equal to each other, we can say that the function is discontinuous. So these are the three conditions, or we can say the 3-step test through which we can know that whether the function is continuous or discontinuous. After having discussion on the 3 conditions of continuity, let's solve one example on those three conditions. The example is that f of x is equal to 2x plus 5, where x is less than or equal to 2, 4x plus 1, where x is greater than 2, at x is equal to 2. So let's try this on the first condition. In this, we have to know that the function is continuous or not continuous. So the first condition is that f of a should be defined. If f of a is undefined, then the function is discontinuous. So in this, we will put the direct value, which is equal to 2. So for direct value, we need to take this one, because if x is less than 2 but x can also be equal to 2, we should take this one as an example. So f of a 2x plus 5, we have taken this because of this equality sign. So let's put the value 2. We are getting 9 here because 2 and 2 if multiply, so they become 4, and if we add 5, so we are getting 9. So look here, is this defined or not? This is defined, so the first condition is satisfied. Now let's move to the second condition. What was the second condition? The second condition was that the left hand limit should be equal to the right hand limit. So we will take the left hand limit at first time, then after that we will also take the right hand limit. So which values we should take? Which expression we should take? We should take the expression, if we are coming, this is right hand limit, this is left hand limit. So here the x is less than 2, so we should take this one here, and actually the x if greater than 2, so we take it at the right side. So let's solve for the left hand limit first. Left hand limit. So in left hand limit, we know that this one is coming, so we should take this one as a left hand limit. So in left hand limit, we can say that limit x tend to a, we will take the sign minus. It does not mean that the value is negative, but it means that we are coming from the left hand limit, is equal to 2x plus 5. F of x is equal to 2x plus 5. So now let's put the value, limit x tend to 2 from the left hand side, f of x, where is x, so put the value of 2 here. So we can get it like 9. So the left hand limit is equal to 9. Now let's try, this one is the a left hand limit, let's name it like 2 so that we don't getting confused. Now let's take the right hand limit. So the right hand limit should be with plus sign, because if we taking the left hand limit with minus, we should take the right hand limit with plus. And as I have said, that does not showing the minus and plus value, but they just only showing the left hand right hand limit. Which value we should take? So we have already written that at this side x is greater than 2, so we should take this value, which is 4x plus 1. So now let's solve it. Limit x tend to 2 from right hand side or right hand limit, f of x is equal to 4 plus 1, which is equal to 9. So we can say that the second condition is also satisfied, because the left hand limit value is 9 and the right hand limit value is also 9. So the second condition is also satisfied. Now the last condition is, last or third condition is that limit x tend to a, f of x should be equal to f of a. That means that the value which we have got here should be equal to the value which we have got here. So as we know that this value is equal to this one, so the third condition is also satisfied. We can say that the limit x tend to 2, f of x is equal to f of 2. So we can say, hence the function is continuous at x is equal to 2. So we can say that the function is continuous. So I hope your concept about the continuity will be clear. So we will meet in next video. Thanks a lot for watching.